Hey everyone, today we are thrilled to have a conversation about really the next step in our species' urge to step off of this planet and explore the cosmos, which of course is the Artemis mission that we're going to have a conversation about. But all of this is under the heading, as many of you know, of the Big Ideas programs of the World Science Festival. And there's really no bigger idea than exploring the cosmos. Of course, you all know me as a theoretical physicist who explores some pretty big ideas, gravity, quantum mechanics, unified theory, and so forth. But just to get us going, I might note that when I was a little kid, I really wasn't thinking back then about being a theoretical physicist. I had two goals for potential careers when I was, I don't know, 6, 7, or 8. One of them was to be a professional bowler. You know, you need to have good hands for that. And clearly I don't. The other goal was to be, you know, like many kids, wanted to be an astronaut. But for me personally, as I began to quickly realize that I have intense claustrophobia, that I get seasick, even in the most gentle boats, even on a swing, I get seasick. So clearly I needed to remove that thought and go back to the library and just play with equations. And that's, of course, what I have done ever since. But our conversation today is with folks who have been utterly essential to this remarkable next step where we are going to go to the moon and beyond. And that will be the conversation today. So let me bring in our first guest, who is Thomas Zurbuchen, who is NASA's head scientist. He's the associate administrator for the Science Mission Directorate, and that directorate has as its mission to understand the origins, evolution, and destiny of the universe. And he joins us from his home just outside of Washington. Welcome, Thomas. Thanks for joining us.
Glad to be here. Thanks so much.
Excellent. And our second guest is Dava Newman, who's NASA's former deputy administrator. She is currently the Apollo Program Professor of Astronautics at MIT, where she runs the MIT Media Lab, and she is joining us from her office in Cambridge, Massachusetts. Welcome, Dava.
Thank you so much. Great to see you both.
So I love your voice. I don't quite see you yet. I don't know if that's trying to illustrate like a black hole or something of that sort. But Thomas, do you see Dava, or is it just a glitch on my end?
Not yet. I just remember when we did the test, we had the same thing. All of a sudden, she popped up. So I hope the same thing will happen. I'm assuming that Dava will pop up, but if nothing else, it'll be like the voice of God, Dava. So you will be with us certainly in audio form, but we hope in visual as well. So let's just jump right in. Thomas, you know, the Artemis mission, it almost launched a couple of times. There was great anticipation. In fact, I was over at CNN the morning of one of the launches, and I learned like 10 seconds before we went live that had been scrubbed. Was this unexpected? Or, I mean, obviously you don't want it to happen, but is it surprising with something this complicated that there would be these glitches en route to the successful launch? Look, the short and the long is it's not surprising, right? It's a very complex mission, a really complex launch vehicle that on top of it has a complex orbiter, the Orion, internationally built orbiter. And what happens as you get then step through the whole launch proceedings, there are things you're learning. And frankly, in this case, it had a lot to do about both the ground system, but also on the rocket, of the entire plumbing and kind of the overall decision-making related to liquid hydrogen especially. It's a well-known problem that, frankly, even during the shuttle era, created a number of issues. And I was just like you. I went to every one of those launch attempts. And finally, on the third one, of course, I saw it lift off the pad, and just absolutely remarkable.
Yeah, that must be an incredibly exciting moment with a successful launch. So congratulations on that. Dave, are you, I think you are with us, at least in spirit.
I can see you. I can hear you. I can see you. I'm here.
Okay, fantastic. Okay, so we have a a very studious looking still image of you, which is going to drive my questions to be a little bit more serious than they otherwise would be, which is fine. But Dava, you're now at MIT, but for a period of time, you were right up there at the top of NASA. So what does the success of this launch mean to you personally?
Oh, it's huge. As the Apollo program professor at MIT, it's been 50 years, but we're back. And it's a completely new era of space exploration, much more democratized frequency. But it's been hard work, and congrats to the entire NASA team, all the contractors. This really took a nation, and it can't be understated. And it's hard. It's hard work. I went to the first 2 launch attempts. I couldn't make it for the third, but the great thing is the third time was a charm, and it shook all of Florida. I mean, that's how impressive this is. Heavy lift launch is something truly special. And I say, now we're back, and so much science and exploring to do.
Yeah, which is great, because Florida does need a good shaking, but that's for a different conversation. But you mentioned the Apollo mission, and that is a name in your professorship at MIT. And look, I don't know how many of our viewers are old enough like me to have remembered the Apollo mission. Certainly some are, but those who aren't, no doubt, have seen films about that remarkable period. So can you give us a sense of the comparison between, say, the Apollo mission and what Artemis is doing and seeks to achieve?
Is that for me, Brian?
Yes, it is.
Excellent. So I love the video that's showing now. And so again, Saturn V and the Apollo program, that's the largest launch vehicle, heaviest launch vehicle we've ever had. And now here's Artemis surpassing it. So it's just really phenomenal in terms of this much rocket power, what we can launch. This is, of course, Artemis I. It'll be followed by Artemis II, which will have the crew on board. So this is a dress rehearsal for the crew on board. And then Artemis III will be landing on the moon. So that's the sequence. Just hard to describe the amount of heavy lift launch capability that they have on this rocket. It takes 3 days to get to the moon. It's far away. And so it's really heavy lift is the way we explore deep space to the moon, but also onward to Mars. And that's why we need this capability. And we're back.
Yeah. So I'd love to talk about Mars in just a moment, but just sticking with the moon for the time being, there certainly will be some who hear about us going back to the moon and, I don't know, not be as excited as perhaps we were back in the 60s. We've been there. Some would say we've already done it. What is the motivation, say, Thomas, for going back to the moon at the moment?
So look, there's a number of reasons we go to the moon, but I think for me as the science lead at NASA, the most exciting one is we're going to a moon that's really different than the one we left in terms of our understanding of this celestial body. An understanding that has truly evolved. The questions that are currently at the heart of science, the highest priority questions as prioritized for us, not by some internal NASA committee, but by the national academies in the United States, kind of include questions of the moon that relate very much to water. Kind of one of the big surprises being that this kind of body without any atmosphere really has water at its polar regions, but also embedded in some of the regolith, kind of as found on the ground. A huge surprise from the time, from our understanding of the moon there. The second one really is our understanding of the actual timing of the planetary system, kind of evolution, kind of our solar system. That, of course, went through massive changes, including changes where outer planets like Neptune started moving out, kind of in a moment of instability that created kind of showers of rocks through the entire inner solar system, which, of course, left scars on the moon. And what the academies tell us, go back and actually date that very much by picking up samples, and do so kind of by creating a collection of samples that rivals the scientific impact that the Apollo samples have had. Those are two of several science topics that really have changed our understanding and interest in our celestial, neighbor here, our moon.
Yeah, I remember, I don't know, maybe it was 10 or 15 years ago, it could be longer. There was a professor who tragically died not long ago, Arlen Krotz. His office was right upstairs. And we'd go on walks along Riverside Park sometimes, and he'd tell me about this idea that there was water on the moon. So it's so exciting to have a sense that now it's really going to be explored. Do we currently have a sense of how much water is there?
So it's an interesting question, right? Kind of, what we have is we have at least 3 observations from space. One of them, by the way, from the Earth, using an infrared telescope in the upper atmosphere. But the others in orbit around, kind of looking at those shaded craters, using different types of radiation, infrared, but also radio and other type of observations. What we really need to do, though, to really turn that into actual quantities, what we need to do is actually go land and pick up some of these samples and actually look at it. Kind of, we need a calibration tie point to really, if you want, knock down the error bars. But just the range of water is in every way related to amounts that would fundamentally change how we explore. And of course, Dava has done a lot of work in this.
And so, David, what do you see as obviously water on the moon is exciting. Water on any extraterrestrial body suggests the possibility, out there of life. That's certainly the motivation for exoplanets. What's the motivation here? Is it to set a base and we can mine for water, or what will the utility of water on the moon give us in these explorations?
So it helps us answer that big question. What about life? What about life out there? Now I'm talking about becoming interplanetary. So for me, as a technologist, I look at the moon and say, this is our chance. This is our chance to demonstrate the technologies and buy those down. We'll get to Mars to really answer that question. Did life exist? But the first and foremost, Thomas mentioned, we'll get to the South Pole. That's where we're going to go to take a look at the ice. We need to measure it, monitor it. Where we have some MIT experiments going to like little robotic ant swarms, if you will, on the commercial opportunities. And then depth field camera as well. We don't have that information to have this technology for future human missions. There's just so much that we need to study. So I look at the whole lunar surface as a test bed to enable our future human missions. And so back down to the South Pole, you see what's the quantity of the ice there. We really have to learn in situ resource utilization. How do you live off the land, no matter where you go into deep space? So these are all the technologies that we really need to demonstrate. Mobility first with a lander first, mobility with rovers, and then our scientific instruments that prepare us for the human missions. When it's the human missions, then of course we need to worry about keeping people alive and the pressurized rovers, in mobile spacesuits, the whole life support system. So these are all the technologies. Now that we have heavy lift launch, that was number one, heavy lift launch. Now we get out there into deep space and we start testing these different technologies to enable the next decade and decades coming for both robotic and human flights. It's not one versus the other.
Yeah.
The swarm of robotic sensors, assistance that we envision is exactly what NASA's teeing up with international partners as well to really explore the moon in this coming decade. It's super exciting, and everyone can participate. Students, faculty, and our international colleagues. It's really wonderful. It really has been democratized. Their secondary payloads on Artemis, those are mostly from schools, and they're just small payloads, high risk. They're, more than 50% of them are working, and that just gives everyone an opportunity to see themselves as participating in space exploration.
So I'd like to explore both of those points a little bit further. First, you mentioned robotics, and there's certainly a perspective among some scientists, I'm sure some members of the general public, that maybe the smarter thing to do would be to just use robots, and we don't have to worry about all the dangers in technology that's developed to preserve life in environments that are so hostile to at least life as we know it. Why not just do robots? Why have people involved in this?
So if you don't mind, Dava, sure. If you don't mind, you could make the same argument about the Antarctic and volcanic activities on Earth, right? There are hazardous areas where you could go with robots and you could explore. And what the top scientists do, whether it's at MIT and every other university around, what they do is they go there in person. They also bring robots. But the right way to explore volcanoes, even though it's dangerous, is to bring somebody with judgment, somebody with tremendous insights, kind of reading the environment and understanding the science, and somebody who, of course, then is supplemented, complemented with robots to get kind of an exploration program going. So why would the moon, why would Mars be different, Dava?
Yeah, so I love that. And so we've been exploring Mars for 50 years with our orbiters, and then our landers and our rovers. And that's amazing. And so all that data we have back, but I submit the first human mission that we send will surpass in terms of mobility with that, the human intellect, the high value added science. We're going to have our rovers and robots with us. Amazing what we're doing right now with Perseverance and Jezero Crater. All this is great data, but you add on the human component, and our chances just really went up significantly to find that evidence of past life. So it's a combination. It's exploration teams, and we are out in the field. We're doing analog studies, and it's always people, and it's always our machines and rovers together. So it's really very synergistic. Just make sure the humans are doing the high value added for humans. Make sure your robots and your robotic systems are doing the high value added, the precursor, collect the data, run 24/7, because then the humans can make the decisions. Oh, this is the best, highest value scientific, waypoint that we need to study. So it really is a team working together. And, there's always humans on the mission. Even if it's a robotic mission, we're back here at Mission Control, putting input into the system. So I always say there's always humans and automation and robots involved in any space mission.
Makes sense. Absolutely. So Thomas, if you can just give us a sense of where are we right now with Artemis? So it launched, I guess, a couple nights ago. I admit that I was otherwise preoccupied, so I didn't actually get to watch this one. Where is the Orion capsule now, and what's the plan from here toward splashdown, which I guess is sometime in early December? Is that correct?
Yeah, so basically it launched, and just the one thing I want to tell you, Brian, and I know you appreciate that, is that the models that we had of the propulsion, the 8.8 million pounds of thrust and the entire orbit within 0.3% of what the performance was close to the prediction. It's absolutely amazing. Right down the middle. Yesterday morning, it did a burn and went into orbit around the moon. So yesterday evening, looking into the sky for the first time, in my entire lifetime, is a human-capable, system in orbit out there that I'm looking at, and I'm just so excited. Friday is the second burn that we're going to do. And right now there's high-resolution imagery showing up. You see it around on social media. We're going to release them like we always do. On the 5th of December, we're going to leave the moon and come down on the 11th of December and complete that test flight. Remember, there's a lot of mission to be done ahead of us because of the fact that one of the key risk items, of course, that entire entry descent and that thermal protection part of the system, which is so critical for human survival, of course, when we come back. So
that's the heat shield, I gather.
Exactly, the heat shield, the Orion heat shield, and really the parachutes, all the relevant systems that actually protect the human lives as we go down. So the next flight will be the one with astronauts, 4 astronauts sitting on top of it for an Apollo 8 circumlunar flight. So we're really in the middle of it. Things are going well. We are, of course, encountering some issues. That's what you would expect. The same is true even with the James Webb Space Telescope. Everything went really, really well. We worked issues, and the team is doing really well with Artemis right now. The issues they're encountering. The international team with Orion really working together hand in hand. Just a wonderful moment in time right now.
Now, this is an uncrewed mission, but I gather that there's kind of a crew, right? There are mannequins. I've heard that you have renamed moonikins, if I heard that nomenclature correctly. So can you just give us a sense of who's on board? David, why don't you take it if you
Okay, there's absolutely. Well, so that's a mannequin you see there as in the crew seat. That's really important. Again, instrumented, taking all the data. We want to know the whole profile of the mission for the next mission, which has the humans on board, and Snoopy's there as well. So I don't know if everyone's seen the little orange Snoopy, which is scientific, because when Snoopy's floating around, can definitely give us show us the weightless environment or the microgravity environment. You always want to take Snoopy on all your space missions. Actually, when the crew go, they wear their Snoopy cap inside of the spacesuit when they go out. So it really is a complete dress rehearsal for the next mission, for when the humans are aboard. So everything is as realistic and as similar as possible to make sure that you want to do the dress rehearsal then for Artemis II, the upcoming flight with the crew.
And what sort of dangers or measurements are you making to be aware of potential dangers when there's life on board? Radiation measurements or things of that sort? What are you actually doing?
So radiation is deep space. So again, we've been in low Earth orbit for the last 40 plus years. So now we go back to deep space. So absolutely take radiation measurements. What's about the vibration, especially on launch? Thomas mentioned when we come back in. So you have to categorize the entire loading, the vibration envelopes analysis. Hopefully that's a few Gs, a few times body weight loading, and thermal. Thermal is of the utmost importance. You're coming in screaming, literally screaming back to the Earth's atmosphere. And the Orion vehicle is magnificent. It's designed for that. But everything will be monitored, thousands of sensors to really capture that thermal environment, the stress environment on the loads, the vibrations, everything coming, and make sure we keep our astronauts very safe and well on approach and landing back to Earth.
And so, Thomas, what do you think the time frame is going to be between the measurements that are taken on Artemis I and the next Artemis that is meant to be crewed? Is that a year, 2 years, 5 years? What do you think it's going to take?
The plan right now is just because of the supply chain issues and everything is close to 2 years. So that's what we're already working on it. If you go visit Mississippi, walk in there, you see the rocket being built right now. There's a lot of signs that you're talking about, Dava, that a lot of will be analyzed. Of course, it's the radiation vests on these models that, German and Israeli build radiation vests that are doing their work, really trying to see how we can protect them. I think the one thing I want to mention, Brian, is that we already created a record, and we'll do so again by really bringing life from Earth into deep space. We're actually extended in dimension, kind of in distance from the Earth, kind of the time we've ever brought earthbound life. And of course, we brought fungi and we brought single cell organisms, all of which are basically doing active measurements of really the radiation environment and how the evolution in that environment is in fact progressing. So a lot of this work very much in the center of biological and physical science type of communities that are really interested in this. Again, a lot has happened since the Apollo program, so it's time to kind of bring all that knowledge to bear.
Yeah, I mean, when you think back to Apollo, I mean, just comparing the computational capacity back then and today, I gather there are two redundant computers on Artemis, each of which has its own two redundant computers. So you've got multiple levels with computing power that's thousands of times, it must be thousands of times greater than what was on Apollo. Just think about, your cell phone compared to what things were back in the 1960s. So were those astronauts crazy back in the 60s for getting into the Apollo mission with that comparatively rudimentary capacity that we had back then?
Well, I think, innovation and the most innovative project and crazy project were really, really similar at the beginning, right? Yeah. And I just really believe what the Apollo program is a demonstration is how much humans can achieve if they truly work together and bring the best out in each other. And in my mind, having sat with the Artemis program and especially recognizing how much more diverse and much more international the Artemis program is, I have no doubt, I already see it now, how even more we can achieve with that kind of team. And again, there will be moments where what we're trying to put ahead of us, landing on Mars, and coming back from it will sound crazy to many people, but that is how innovation looks in its early stages, just before, what is science fiction through science becomes reality. So I really, to me, Apollo has always been a huge inspiration because of the value of teams coming together, doing the impossible.
Yeah. David, when you look at photographs of the astronauts in the Apollo mission, if you sort of squint your eyes to first approximation, they all kind of look the same. And there's a wonderful commitment to change that going forward. So can you give us a sense, from the time that you were at NASA and from what you're aware of going forward, what that commitment is and what the future missions will look like?
Yeah, most simply, is space for all. And so when we go back, so that, those gentlemen all look alike, and they were amazing, amazing test pilots. Again, maybe a little bit crazy, but what Apollo first taught me to dream. As a young girl watching it, you taught us to dream. Surely, as Thomas mentioned, if we could focus, we could get humans to the moon. Now, the message is it's for everyone. Look at this diversity of our astronauts. Yeah. The first woman will step, onto the lunar surface. There'll be international crews. Of course, we come from. It's a representation of the world and the globe, and every young person out there listening to us, he, she, they should see themselves. They should see themselves represented, because they're all superstars, right? We want them to all take our jobs. That's the hope and the inspiration, is to make sure that all of our kids can see themselves, and they realize also just how fortunate we are to be back at the moon today. I mean, I'm actually a little giddy. I can't believe we're having this conversation. We are in orbit around the moon. I've been waiting a long time to say that. We are in orbit around the moon, and that's for all humanity. You mentioned the computation, millions of times more capable. And now we can actually get that data even in real time, very close to real time. We have a short delay for the moon, but that's really important as well, because a few lucky astronauts will go on the next mission in orbit, then land. But guess what? All of the data, all of the science, all the technology, that's for the world. Yeah. So I hope that everyone listens to this. This is for you. This is for all of us together on, this really inspirational focus to become interplanetary.
Yeah, inspiration is indeed the right word. It's wonderful and remarkable. And David, you've also done groundbreaking work in trying to make the human experience in space more bearable, because if it's going to be open to a wider group of individuals, those clunky spacesuits that we're all familiar with, they've got to have an upgrade, and you've been a pioneer in that regard. So you can give us a sense of what you've been doing there.
Sure, we've been working on that. It's a kind of a change the design paradigm. We kind of take the human body and I design a pressure layer, if you will, from the person out. I want to enable mobility, have a very light system. We learn a lot from the current technology. That's the gas pressurized suits. But the current one on space station, 140 kilos, a very heavy suit. For the Artemis suits going forward to be pressurized as well. We really look forward to demonstrating some technology, maybe hybrid. Your arms and legs, you really want to move. You want to move well. We don't want to waste your energy moving a gas pressurized suit. Of course, you need the pressure layer. That what the pressure is doing, you're in a vacuum. You're in the vacuum of space. On the moon is a vacuum. So you need the pressure layer. Then you need the whole life support system. Providing your oxygen to breathe, scrubbing out your carbon dioxide. So it's a great engineering challenge, but rather than taking the spacecraft and shrinking it around the person, I'm going to say, let's take the person, or, like the, Olympic athlete, we're in the World Cup nowadays, and let's take that amazing capability of the person and design the life support systems around them.
And so what does it feel like to be in one of these Christian Dior spacesuits?
I wish. I need them as a sponsor. That'd be great. Well, you're overpressurized. So it's 1/3 of an atmosphere. So the pressure production that we need for any spacesuit, gas pressurized or directly on the skin, is 30 kilopascals, or 1/3 of an atmosphere. So when you're in the lab and doing the research and development, you're at 1 atmosphere, like we are having this chat, and we overpressurize to 1.3. It feels tight. It's okay. You jump into a vacuum chamber, and now you're in a 30 kilopascals, 1/3 of an atmosphere. Feels great, if you're in in the real test chamber for a vacuum test chamber. So it'll feel, fine when we're there, but pressure is just part of it. You really need all your thermal control as well. You need all of your other life support systems. And again, going to the moon is really cold or, really hot. We have, plus or minus 200 degree temperature differentials. So also the thermal, we paid a lot of attention to how do you still be very mobile, but we have to think about the thermal properties. And we mentioned before, radiation for human missions in the future, radiation in deep space is the number one challenge.
And how, I'm focused on digits these days. What greater facility does this give for the fingers to be able to do more fine work in space?
It's really important. The design of a glove, if we can make it tight fitting to the hand, I have more degrees of freedom here in my hand, my fingers, hundreds of degrees than my whole body combined. So the glove design, and that was actually the number one complaint from the Apollo astronauts. I mean, they were great. They had the right stuff, but they really beat up their hands. They would have loved to had more mobility in their fingers to do more work and more mobility to, you see the 2-foot bunny hop, that was because the suit had limited mobility. So they would really like to have natural human performance as they can, because we're not going there to sit around, we're going there to work. So do science, do work. So we really want to enable, empower the astronauts to have as much mobility, hand dexterity as they possibly can.
So how close are you from prototype to actually implementation? Thomas, will these be the suits in Artemis II?
Dava, are you working with any one of the companies with these particular suits?
We are because the folks the industry folks who are working with the suits, we're great friends from academia. Our job is to push them, show them, hey guys, look at this technology. We want, so again, maybe some hybrid, again, test bedding, since we're going to the moon, let's try out some of these advanced technologies. So we really want to infuse some of our technologies. Will it be a complete biosuit shrunk wrap person? Probably no, that's not under contract, but we work really closely with the industry folks, and they have the appetite, especially folks going in the future, the private folks, they have the appetite to fly the best technology possible. So matter of fact, just last week we were all talking industry and academia, and what we bring, is some technology and some different thinking, and we work together well, because at the end of the day, the industry folks too do need to provide a flight qualified system. There's no change for that. So we need to work together so we can flight qualify, keep the astronauts safe and well. So it'll be a team effort, I hope, between the universities and industry as well as NASA, of course.
And Brian, what I'm really excited about, and the suits are really a good example, right? When the Apollo program was started, it was done so largely, not exactly, but it was done so with a very strong government focus. With some contractors very much in isolation, kind of really focused on that government entity, and that's one of the key elements of the Artemis program. That the commercial and kind of academic partners are such an important part of any one of those activities, as are the international partner. The European service module right now attached to Orion is actually propelling it going forward, and kind of I love the suit example that we're talking about, with Dava being a key innovator on it, but that's what we should be doing. As the Apollo has borne a lot of fruit, it has created an industry. So let's actually partner with that industry instead of going back to a paradigm that was necessary at the beginning, but is no longer the best paradigm today.
So given industry as a vital partner, as both of you have mentioned, everybody who's watching this is well aware of the privatization of space travel from Blue Origin, SpaceX, and so forth. So Thomas, can you give us a sense? I mean, do you consider this to be a competitive between government and industry? Is it fully symbiotic, or are you all working hand in glove? What's the relationship between, say, you and SpaceX and Blue Origin?
So first and foremost, we're enormously proud at NASA to have spawned kind of a series of companies and innovators that have taken, in many cases, technology from NASA and have made it kind of into products that we now can buy. So kind of practically how that looks to us, Brian, kind of from the Science Mission Directorate, is that the cost to orbit, of a mission, whether it's an astrophysics mission or one that looks at our most beautiful home planet, that launch capability actually has tremendously become cheaper. So even during my time at NASA, which Dava and I overlapped for a few months there, but even during my time at since that, just the last 6+ years, the overall cost to launch has gone down by more than 15%.
Wow.
And so for us, that's just enormously successful. So frankly, we don't want to build, with very, very few exceptions, systems that we can go buy out there if there's multiple companies. That is good. Now, I want to just tell you, Brian, there is a very human part to it that we should not go kind of ignore. And that is that there's amazing people, let's say at Johnson or at Marshall, that have done a specific job. And one morning somebody says, we don't need this anymore. And I just want to make sure that that transition, that kind of human kind of transition is kind of recognized as such. You know, those people that were successful, that's why we have those options. And sometimes, you know, when I see in social media especially, you know, people kind of don't quite recognize the enormous achievement of those individuals who, of course, are being trained to do other amazing things. We want to be at the bleeding edge of what's possible with NASA, and there's a lot of possibilities, but that's how I see it.
And would you say that there's a complementary role in the zeitgeist of space travel? I mean, some would say that NASA as a government agency has to focus more on human safety. It has to focus more on minimizing risk than, say, a private company like SpaceX or Blue Origin. So maybe the private industry, let them do the more risky stuff, try it all out, and then once it works, maybe then absorb the insights back into NASA. Is that the kind of rhythm that one imagines going forward?
So I think it's absolutely clear that the best set of opportunities we create within the country is by all of us being best at what we do. So, for example, the James Webb Space Telescope, and I love your necklace, Dava, you know, I've seen it there. Kind of that is something that no private company today would entertain, right? It's very, very, very complex. There's so many new technologies. That's exactly what we should be doing. However, after we've developed those things, you know, there are companies that are out there developing, for example, Earth observing systems. And yes, they can make them cheaper and they can launch a few, even if they break first. And, you know, like they don't have to go to Congress to testify whether or not that was worth the taxpayers' money, because they're working with the investors directly. And what we can now do, we can buy those data and make them available for the scientists to do it. So together, we can do, by us being best at what we're bringing to the table, we can together do more than any one of us together. It really is a symbiotic, it's a complementary relationship that I think has the most promise here.
And what will the next step then be with all of the players contributing? Are we going to colonize the moon? Are we going to have a permanent base there? Or what do you think is going to happen? Dave, I see you shaking your head in the negative. Tom, I thought I saw the affirmative, so I'm just curious where you stand on that.
I'm just shaking my head for the. We're not going to colonize anything. I hope. I mean, I hope we've run that experiment. Didn't go so well. So again, we need to go as explorers. And I just object to again, we really are thinking about democratizing it to the public-private partnerships. I want to.
Is that just the wrong word? Is that just the wrong word that I used? Do you think, or is it really fundamental? I mean,
I think it's fundamental. I think it's fundamental. Why would we colonize? That's a very human-centric, a very Western-centric. Why wouldn't we go there? Again, how we're really going to get exploration right is go live off the land. And so I think the change in cultural attitudes that we're all in this together for all living things, past and present. So it is the terminology. We're going to go globally. Hopefully it's again, it won't be one nation state. If we can pool our resources together and our great ideas, we'll go representing humanity. And actually, I think Apollo did that for us too. It was humans that went to the moon. Sure, NASA did stuff, but people were so proud that humans got to the moon. So I think if we follow in that vein, that humans are now back, with our brains in orbit, and our spacecraft around the moon will land. But I think going forward, again, then with that humility that it is for everyone, just so it's a different mindset. And then we're going to do it. We need governments. Absolutely, governments and NASA is funded, so you need that government support. To your point, and governments should, I think, also they do need to actually take the risk, look beyond. So that's why Moon and Mars. That's what NASA, it has to be out there on the forefront, taking those risks. The companies are incredible, and guess what? But they also have a bottom line. So if the business case closes, that's why it's going to be low Earth orbit. What can you do that the companies can do to make more of a business? So it looks really good for low Earth orbit. Again, for the Moon and Mars, this is deep space exploration, in my opinion. And we go there, especially to Mars, find evidence of that past life that was probably there. The evidence is mounting. But we do it together. We invite everyone. And that's, as Thomas said, everyone has their own expertise. And so it's that teaming arrangement, how we can have the private folks, government folks, and the academic folks, how we can all work together best.
Is there a real version? I'm just wondering, is there a real version of unobtainium? You know, the imaginary element on Avatar, the Avatar series, is that something? I mean, are industry folks thinking in that direction, that they're going to exploit the resources, hopefully in a positive way? But is that what's driving some of the public-private partnership in this?
There's some ideas about that. That's not, I think that the inspiration to me, again, is get it right, go beyond, become interplanetary, let people dream, find it scientifically, find the evidence of life elsewhere, where the evidence is mounting, we're going to find it. That's why we need our ocean worlds missions as well. Where are we going to find life, just in the solar system, the exoplanet? So again, given both of your backgrounds in space science, it's just amazing. It's amazing how much that we don't know. Back to James Webb, just really investigating, finding out, dark matter, dark energy. That's breakthrough. That's science. It's a revolutionary, breakthrough science. And so when you look at it across the world, there's roles for the government and for individuals, private entities. And so I kind of think that it just kind of depends on how far away from Earth you go. I think the world, governments are going to need to prop up the exploration, the far scientific exploration.
And so, Thomas, what do you think about the next step? I know part of the Artemis mission, I don't know which number it would be, 3 or 4, maybe 4, you tell me, that's meant to head out to Mars. So is that on a timetable that you can actually give us a sense of now, or is that too much in the future to speculate?
So let me, before I answer that question, let me just quickly give you where the body language disconnect was between Dava and I. It was not about the point that she made. I actually fully agree with her. The one thing I wanted to say, that it's certainly our goal to create kind of a presence at the surface of the moon, kind of that is really allowing us to take advantage by creating vehicles, for example, that both can be crewed, but also can be autonomous, and then kind of do, for example, collect samples of the type that really answer those fundamental kind of science questions that relate to our history, the history of the solar system. Also, kind of opening up exploration areas that look at the universe in ways that, frankly, we cannot from Earth, like the dark ages, where basically any observatory on Earth or in space near the Earth is overwhelmed by the radio noise of both the sun, the Earth, or giant planets. The moon can create things like that. Well, so look, we are at Mars already with robots, and we have been there for a while. And with the human exploration part of it, we have basically said, well, really, sincerely, we're already now, of course, looking at technologies for that, but the human missions will really be kind of in the late 30s, and kind of where we're really focused towards that objective. And there's a lot of work that remains to be done. Kind of any kind of mission at the moon is actually creating tool sets that we will use going forward, including, of course, the gateway, which is really kind of a space capsule in which we'll learn how to kind of survive for a long time in deep space with humans, which is very much analogous to kind of a transit time, which is multi-month kind of away from it. You have seen just recently, Brian, the technology demonstration we did just 2 weeks ago on top of a launch of a weather satellite, where we inflated a heat shield on the way down and kind of demonstrated that this 6-meter heat shield in this case could survive kind of entry on Earth, it needs to be 3 times that amount, but that would take care of one of the core technology worries that we have at this moment in time for humans. So we're already very impatiently pushing towards that, but my guess is it's not Artemis 4, it's beyond that. We're going to do multiple Artemis missions to the moon before we get going on our journey to Mars.
And so you both anticipate, and again, I take the point, David, that the connotation of colonization is the wrong way of approaching it. But I imagine when we think about Mars, will NASA be planning that as a one-way mission in terms of the folks that are going, or are you going to do it as they're going to go and come back?
It's going to be so into the moon. I love the moon. You know, actually from MIT and our space exploration, we call it to the moon to stay. So just so that we're all on the same page. Again, that's what we want to do. We want to be on the moon and learning, and we call it be there to stay with humans, with robots, you know, back and forth. When so both Thomas and I are kind of, again, shaking our heads here because we know it's a round trip. It's with humans, it's a round trip mission to Mars. And it's even going to be a round trip. We got to get these samples. We're taking amazing samples today on the surface of Mars. So the next Mars mission is sample return. We need to get those samples back to Earth. So we're going to learn so much from the currently stowed samples that we're taking right now with Perseverance. So that's a round trip as well, you know, so we got to get those samples back, and then envisioning the human missions are round trip. That's ethical. It's think about, we talked about Antarctica before. Antarctica is not populated. You know why Antarctica is not populated? People don't want to live there. It's really cold. It's isolated, confined. Mars, 100, 1,000 times worse. You know, moon is 3 days away. Mars, 8 months. So sure, we want to go there as explorers, but guess what? Everyone's going to miss their family, their friends. Everyone you know and love is right here on, you know, spaceship Earth, on planet Earth. So it's really thinking about it in round trips. And I love to think about just having that space infrastructure. When you can take a space plane to the moon or lunar orbit, you can maybe go to Mars. So I look at it as, you know, humans literally living off planet and having those options in a transportation system to go to the moon or Mars longer term.
And I gather part of the key to that will be related to what we discussed before. You need to be able to mine your own fuel as opposed to carry your fuel. So where do we stand on that?
I think we're hitting it out of the park. Hopefully we have MOXIE, the MIT experiment. So it's in situ resource utilization, or ISRU. We take that carbon dioxide Mars atmosphere. It's very thin, you know, 1% CO2, but we take that, and then essentially from the CO2 oxygen, CO2 environment of Mars, we split off the carbon atoms, and then recombine the carbon to C2, and you're left with still carbon dioxide. So it's kind of like a reverse fuel exchanger, if you will. Take in the carbon dioxide, split the carbon and the oxygen, recombine, and then we're left with oxygen now. So why are we making oxygen and O2 on Mars? Simply so it's a technology demonstration, an unbelievable technology demonstration. We can make it like 6 grams per hour. So it's not enough to keep you alive. And you mentioned the first and foremost, the primary use is to demonstrate for fuel. If you have your oxygen supplies, if we can create oxygen out of the Martian atmosphere, then you know you have your fuel tank for a round trip. So it completely changes the architecture of a human Mars trip. If you can make your fuel, if we have fuel depots, if you will, for that first, second, all the missions, do you have enough oxygen? And can you think about that on the return trip? Secondarily, it might be for the spacesuit, keep people alive. But first and foremost, it would be for fuel, for propulsion, for that return vehicle back from Mars to Earth.
Just heading in a somewhat more speculative direction as we reach toward the end of our time. David, you noted that in some sense, the old spacesuits were as if we took the space vehicle and shrunk it around the person so that the pressurization that they experienced in the ship would now be mobile and they could walk in their own mobile version of the rocket ship. That, of course, is trying to create an environment that fits human life as we know it. Can you imagine a time when we might change the genome or change the makeup, volitionally, a kind of volitional intelligent design, if you will, which is the language used by a friend of mine, Martin Rees, so that we would have individuals that would be tailor-made. Their physiology would be tailor-made for the harsh environment. So for them, it wouldn't be harsh. And in that way, sort of change the calculus of what it would take to have a permanent station, say, on the moon or on Mars.
It's a great question. And looking into the far future, the first thing that I think about is actually radiation protection and keeping our humans very healthy and well alive. And so if, now this isn't messing with our genome yet, if there are radiation hard folks who are resistant to the harms of radiation, let's them then.
Just naturally. You're saying naturally.
Naturally. Yeah, hypotheses that some people might already have this protection. So that's incredible science. And of course,
is there any evidence of that? I mean,
there's some hypotheses. And why is that so important? Well, it's important for cancer here on Earth. That's why I'm so excited about it. You can find those genetics, find folks that are not predisposed to radiation damage. That would be huge. So if the science unfolds and we have that evidence, then absolutely those would make the best candidates, because it's all about, again, round trip, bringing people back alive and well. And then we'll learn as we go in terms of protection and sending folks. You asked about also the let's give people the best chance that they can. Absolutely. So in terms of nutrition, in terms of all of the physiology that I say, the muscles, the bones, keeping them, really at top performance is how, I think that the science and the experiments will unfold to keep people, in great shape, well and alive. And we learn about aging. We learn about so much in terms of the pathology here on Earth. So that's really the benefit, is thinking about the Earth applications if we're really pushing not just our technologies, but our scientific understanding for deep space exploration.
And Thomas, just jumping off from that, you mentioned earlier, I think both of you did, that we want to have a partnership between a live human being and robots, as that's perhaps the most powerful way that we can go forward now. And of course, that makes a lot of sense with the state of robotics now, where there's clearly a difference in judgment and certain kind of cognitive capacities that a living system has compared to a robot. That's going to change, with AI and deep learning. So can you imagine a time, perhaps even in our lifetime, where it really will be sending out the artificial life system and they're able to do just as good as we, if not better, when it comes to issues like judgment?
So I always think about the progress we've made in AI, and then I look at the spell checker and the iPhone, and I'm deeply disappointed. It's trying to guess my words, and it comes up with words I have no idea what they mean. So my point is, there's still ways to go. I do believe we're making a lot of progress, right? Even just if you look in our lifetimes, how our little companions in our pockets, how they have kind of affected how we're going. Like, no, we're not driving up to the restaurant to figure out whether there's space there. We we have information that comes to us on Mars, right? One of the things I'm so excited about is, we have an astronaut standing on the surface of Mars, right? Sure, they will be accompanied by a flying robot that will help them figure out which direction to go, roam, and find the most relevant rocks. And I really do believe that development, again, with individual robot, but also just that connection to how we're using information is going to dramatically shift and change as we go forward. Even here on Earth, 10 years from now, we'll be in a different place than we are today. Just look where we've come from in the last 10.
Yeah, without a doubt. Let me ask you both one final question. Start with you, Thomas. So I started this conversation, I don't know if you were within earshot when I began, knowing that, like many kids, when I was a kid, I dreamed of being an astronaut, and quickly realized that I was not one of those endowed with intrinsic physiology that was well suited to that kind of an undertaking, claustrophobia and seasickness and so forth. So I will never go to space, sadly. If there is an opportunity, Thomas, for you to go to space, would you take it? Is that something that you would want to do?
It's interesting. If you asked me that question 5 years ago, I would have said no. And I did say no in many interviews. And the answer today is yes, absolutely. And frankly, I became an astrophysicist because of the night sky. It always attracted me. I thought it was amazing that we could build robots. But I'm compelled by the progress we've made, and really excited about the opportunities that are provided to us by crude, exploration together with robotics. So if there's an opportunity, surely I will go.
And Dave, I'm going to give you the last word. Are you going to take that prototype spacesuit and put it to real work out there in space?
I would love to. I would go in a second. I am going to come back home, and more importantly for me now, it's my students that are the new Artemis astronauts, and will be the first astronauts to go to Mars. So kind of paying it forward. So it's going to be, I think, hopefully, one of our students or someone listening to this, they're going to be the first folks to have boot prints on Mars, and it's our colleagues and friends and students who are already in the Artemis crew. So that's it's just an incredible future. There's going to be a lot more people in space. There's going to be, I think, a lot more in low Earth orbit. It'll be fantastic. We'll be working and manufacturing and doing a lot there. And so a lot more people are going to have the opportunity to fly in space. And that's a future I want to live in.
Yeah, it's wonderfully exciting. And so congratulations to you both for all of the work you've done to make what we're now seeing come true, and all the work that you've done setting us up for the next stage as we go forward to the moon and beyond to Mars. And best of luck going forward. And thanks for spending the time with us today.
Thank you so much. Go Artemis.
Thank you. Go Artemis.
And for everybody else who's been watching this program, please note that World Science Festival is coming out with a whole variety of interesting programming. If you've missed any of our previous episodes, you can see them at our website, worldsciencefestival.com, or on YouTube. Programs on psychedelics and on the nature of dreaming are two recent ones that I think were quite wonderful. So if you haven't seen those, they're definitely worth your attention. And going forward, we have some wonderful programs on the ancient history of our and related species, as well as a look at the human brain, cosmology, quantum entanglement, quantum computing, deep learning, artificial intelligence. So you should definitely sign up to the World Science Festival YouTube channel and to our newsletter to be kept apprised of these programs as we release them. Great. So thank you for joining us, and I look forward to seeing you at our next live session. From New York, this is Brian Greene.